Dear students, welcome to our class on demonstration of factors affecting the receipt of solar radiation on the earth surface. Factors affecting the distribution of solar radiation on the earth surface. Now, here you are seeing me right now in the sun. So that means, this is the sun. The sun's rays are directly falling on me. Now, I am going into the shade of the tree. So, the solar radiation is cut off. What is now falling me on is a diffused radiation. I am now in the diffused radiation. Previously, I am in the direct solar radiation. Now, this solar radiation received on the earth is influenced by basically two factors. Okay, number one, astronomical factors. Number two, geographical factors. See, as far as the astronomical factors are concerned, I would like to impress upon you that the solar output is the first factor among the astronomical factors. What is solar output? Now, you see, solar output, okay, the sun behaves like a black body. As I told several times, the sun behaves like a black body. So, energy radiated by the sun depend on its temperature. So, because we presume that the sun acts like a black body, the energy that is coming from the sun is influenced by its own temperature. That means sun's own temperature. Now, in accordance with the Stefan-Boltzmann law, okay, this is a truth. What is the truth? What is the scientific finding? What is the scientific establishment? The energy radiated by the sun depends on its temperature in accordance with the Stefan-Boltzmann law. This is established fact. So, assuming the temperature of the sun is 5800 degrees Kelvin, okay, the solar output to space is 2.33 into 10 to the power 25 kilojoules per minute. This much per minute. But only a tiny part of this energy is received or intercepted by the earth. Why? Because it is a very small body. Earth is a very small body in the solar system. So that's why. Okay, the reason is that the energy received is inversely proportional to the square of the solar distance, that is approximately 150 million kilometers. 150 million kilometers. What is this 150 million kilometers? The solar distance. Once again, I would like to impress upon you, only a tiny fraction of the solar energy intercepted by the sun. From the sun, how much you are getting? From the sun, 2.33 into 10 to the power 25 kilojoules per minute. So, why it is so little is the reason is that the energy received is inversely proportional to the square of the solar distance. So, now here the second factor we try to understand. What is the second astronomical factor? First one is the solar output. The second one is the distance between the earth and the sun. Due to eccentricity of the earth's orbit around the sun, the distance of the earth from the sun changes. Earth is elliptical in shape. It moves around itself in one day. It makes one rotation around the sun in 365 days. Now, due to eccentricity of the earth's orbit around the sun, the distance of the earth from the sun changes. That's what in the introductory course I told. Aphelion, perihelion, like that. Okay. So, the distance of the earth from the sun changes. Consequently, the receipt of energy on the earth surface, which, okay, also changes. The earth goes sometimes close to the sun. The earth goes away from the sun. Okay, average 150 million kilometers. So, once the distance is changing, the energy received is also changing. First factor, solar output, we discussed. Second factor, what do we discuss so far now is the distance between the earth and the sun. So, the third factor is the altitude of the sun. Now, you see, the altitude of the sun. Now you see, this is the sun. Okay, what is the altitude of the sun? The vertical rays of the sun heat the maximum possible area. That means over the equator, maximum possible energy is received. The greater the sun's altitude, the more concentrated is the radiation intensity per unit area at the surface. The greater the sun's altitude. So, altitude is more, okay? So, the more concentrated energy we get from the sun. Now you are seeing the sun. Now here, these are the first three factors of astronomical. Okay, we are discussing in this class almost a demonstration of factors affecting the receipt of solar energy from the sun. In that, astronomical factors. The first one what we discussed is the solar output. Second one is the distance between the earth and the sun. The third one is the altitude of the sun. Now we try to understand geographical factors. Okay, geographical factors are one, effect of atmosphere. Atmosphere is a colorless, odorless, and tasteless physical mixture of gases enveloping the earth. On all sides, several times I told, the quantity of solar radiation passing through the earth atmosphere is depleted due to the presence of aerosols. Aerosols. You see, what are the aerosols? This is a small tree. From this, okay, some organic matter enters. Dust enters. Carbon dioxide, carbon monoxide, hydrofluorocarbon, perfluorocarbon released by the industries, released by the transport. So now, the geographical factors, number one is the effect of the atmosphere. The quantity of solar radiation passing to the earth is depleted due to the presence of aerosols. Similarly, clouds also scatter, reflect and absorb solar radiation. So, the amount of solar radiation in the earth is affected. So, what is the first factor in the geographical factors? Effect of the atmosphere, depending upon the aerosols, depending upon the presence of the clouds and everything. Second factor is the effect of the latitude. Now, where I am taking this class, demonstration is 41 degrees north latitude area, 41 degrees. Okay. What is the effect of latitude? Now I am standing in the 41 degrees latitude, northern hemisphere. Okay, effect how the latitude is affecting right now? This is due to the fact that the day length and the distance traveled by the inclined sun's rays through the atmosphere changes. The day length changes here. The distance traveled by the sun's rays onto the 41 degrees latitude is more as compared to the equator 0. Okay, right. Third one is the effect of aspect and altitude. Altitude. I am now at an altitude of 2,300 meters above the sea level. Now, here, how this altitude affects? You see, the solar radiation received increase with the increasing altitude. Actually, as the height increases, the solar radiation received increases. However, the temperature decreases. Okay. Now, mountain areas which faces the sun's rays receive more radiation, while the valley areas receive less. Mountain areas, valley areas. In mountain and valley winds, land and sea breezes. Okay, I told this fact. So that means mountain areas facing the sun receive more solar radiation. Now the last one is the length of the day. As the duration of the day increases, the amount of radiation also increases. The intensity and day duration together decide the quantity of the radiation received. So, the four geographical factors once again: effect of atmosphere, that means aerosols, etc., clouds, etc. Effect of latitude. As you go away from the latitude, the sun's rays have to travel long distance and energy is depleted. The third one is effect of aspect and altitude. The length of the day is the fourth one. Now, here I would like to impress upon my beloved students that now, today is 7th of March 2022. Okay, now you see to my left, if you see, there is a small river going on. That's what is Laramie river, riverlet, which is going to Laramie main river. It is a small water passage. Now here, the tree here, you see here, I am able to see the sun, you are able to see the sun. However, there is snow here. You see, there is snow here. Am I right or wrong? Snow. It is falling on me also now. See, why snow is there in spite of the sun? This is the thing. Factors affecting the receipt of solar energy. Factors affecting the solar energy receipt. So, geographical factors, astronomical factors, what I told. Geographical factors, solar output, like that. Astronomical factors, solar output and altitude of the sun, like that. So, geographical factors mean the distance between the earth and the sun, atmosphere, effect of the atmosphere, like that. See, here, I would like to enlighten you one thing. Outside temperature right now at around 11 a.m. Today, now it is 11 a.m. Sun is there. In front of me, there is snow. Left side, there is snow. A bird is also flying, you see. A bird is also flying. A bird is also flying. It's minus 14 degrees centigrade. Here, what I am interested to impress upon you is that even though sun's rays are falling on me, the quality, the duration, the intensity, these are playing an important role. The intensity is very low here as compared to equator at 11 a.m. at 0 latitude. Okay, maybe 2 to 3 or 4 times more than at 41 degrees latitude. So there is no heat. Once there is no heat, snow is not melting. You see, this is the snow on the tree. Outside temperature is 11. Sun is there. You are able to see me. I am able to see the whole white snow here. This is the thing. Another thing is the sun's rays are traveling long distance. The sun's rays are traveling. Behind me there is sun. Am I right? So sun's rays are traveling, not directly falling on the equator. They are traveling. Energy is taken out by the atmosphere as the sun's rays are slanty. 0, 1, 2, 3, 4, 5, 6, 7. You know, it is 41 latitude. Now as I go, there are there is much radiation energy that is trapped in the atmosphere. So as the distance traveled by the sun's rays are more, the energy is less. These two are inversely proportional. Another very interesting thing I would like to tell you, what is solar radiation itself? Solar radiation is the source of energy that sustains organic life on the earth. Whether trees are there, or whether water is going, whatever it may be, there is energy required. The whole energy is coming from the sun. Okay, direct solar radiation is falling now on me directly. Now it has no energy. What will happen? I am putting so many clothes for keeping me comfortable to take this class. So direct radiation, reflected means something is reflected by me. Now what is the proof? See, you are able to see my shadow. So sun's rays are falling directly. Something is reflected. My shadow you are able to see. Am I right or wrong? You are able to see my shadow now? Right. So why? Because they reflected. Something is reflected by clouds also. Not only my body. Something is absorbed by the clouds. Something is transmitted by the clouds. See, these are all the things that happens once the solar energy falls on the earth's surface or any earthly body. Okay, the terrestrial radiation, that means energy. And now you see a small farm and dog is also there. Some colleagues they are moving on the this thing. See, sun's rays are falling. However, they are putting very warm clothes. Why? Because energy is less, because the sun's rays are not falling directly. The sun's rays are falling slightly, energy is dissipated in the process of reaching the earth. So this is what I would like to share with you, just for your academic interest. I would like to say direct radiation, diffuse radiation, net radiation. What is net radiation? The difference between the incoming and outgoing. Net radiation is minus here now. Even though sun's rays are there, net radiation is minus now. Okay, here net radiation is minus. Very interesting. I measured it in the laboratory today in the university. I had gone there. So, see, sensible heat, ground heat, latent heat, all these things, combine into the energy balance. Net radiation is equal to, what is the equation of net radiation? Net radiation means the difference between the incoming and outgoing. RN, net radiation is equal to sensible heat, the energy utilized in heating the air. No energy. The energy that is going into the soil, ground heat flux. Latent heat flux, the energy utilized in the evapotranspiration of the tree. Tree itself is snow. Where is evaporation and transpiration going on? Only little is evaporation. So energy is less. This is what the energy balance. Also, I would like to discuss with you. Not solar radiation balance, energy balance. Rn is equal to net radiation is equal to sensible heat A, latent heat La, ground heat G, plus miscellaneous energy that is stored in the plants or trees or anything what you are seeing. This is what I would like to share with you. All the best. Study well. Please have faith in you that you are going to be wonderful scientist in agriculture meteorology, and you are going to shoulder the responsibility of food security in the world, in the nation where you live and everything. May God bless you. Study well. Have highest moral values. Never and ever you do even the smallest of the small mistake. Never and ever will you hurt any human being. Just try to be a great human being, great scientist, wonderful. All the very best. May God bless you. Thanking you for your patient hearing. Yours, Radha Murthy.